Hello dear students. So next we'll be considering the second numerical. For second numerical, our numerical is there is a simply supported beam AB. In this AB beam at C point there is a 3 kilonewton load at a distance of 3 meter, and at point D at a distance of 5 meter from the A there is a 5 kilonewton point load, and UDL is on the span of 3 meter from the A point. This is a simply supported beam, so we'll solve this particular beam for calculation of shear force and bending moment. So before going for the shear force, very first step of our solution is to calculate the reactions. So to calculate the reactions, first of all we'll take summation of moment at point A clockwise positive equal to 0. So as we are considering moment at A, so rotate all the forces towards the moment. So first of all, this UDL is of value 2 kilonewton per meter. So convert this UDL into point load. So 2 into 3, 6 kilonewton will be the conversion of UDL into point load. It will act at the downward at a center. So 2 into 3, this will be the intensity. It will be acting at a distance half. So into 3 by 2. This is our first force. As it is rotating in the downward, in the clockwise direction, it will be considered as positive. Second, 3 kilonewton force. Again it is clockwise. So 3 into distance perpendicular is 3 meter. 3. Next 5 kilonewton, again it is rotating in the clockwise direction, so positive 5 into the distance is 5 meter. And this RB is rotating in the anti-clockwise direction, so minus RB into the distance is 3 plus 2 5, 5 plus 2 7 meter equal to 0. So from this equation, RB will be equal to 6.14 kilonewton. Now, summation of Fy upward positive equal to 0. So, RA is going upward, RB is going upward. Then, downward will be minus 2 into 3, that is UDL, minus 3, that is point load, minus 5, that is point load, equal to 0. So RA plus RB equals to 6 plus 3, 9, 9 plus 5, 14 kilonewton, 14. Okay, so RA equals to 14 minus 6.14. So it will be RA equals to 7.86 kilonewton. In this way we got RA and RB. Now we'll move towards the shear force calculations. So for shear force calculation, calculations, we'll consider a section at a distance x from left side between A and C. So consider any section at x in A and C. So if we are considering the section between A and C at a distance x, so Fx will be equal to, this is RA is 7.86, so it is upward, so positive 7.86 minus, now we have to convert this point load in the x span into the, convert this UDL at the x span to the point load. So intensity will be 2 into the span, that is x, and that will act downward, so negative 2 into x. So this is the section in between A and C. Now if we put x equal to 0, so FA at point A, x is 0. So FA will be equal to 7.86 kilo Newton. Now at point C, x is equals to 3 meter. So if we considered FB, so put x is equals to 3 meter. So FB will be equal to 7.86 minus 2 into 3. And the answer will be 1.86 kilo Newton. Okay. Now shear force at any section from C to D. So now this from C to D, if we considered any section, so Fx will be equals to, do the algebraic sum of forces either on the left side, either on the right side. On the left side there are 3 forces, so we'll consider right side. On right side our conventions are downward positive and upward negative. So downward positive, so 5 kilonewton will be positive and RB will be negative. So 5 minus RB is equals to 6.14. 6.14. So the answer will be minus 1.14 kilonewton Fx. Now we'll consider shear force at any section from D to B. Now between D to B, any section. So Fx, again you can consider the right side as there is only one force, and on right side upward is considered as negative. So RB is considered as negative. So RB is equals to 6.14. So answer will be minus 6.14 kilonewton. In this way we got the shear force. Now we can draw the diagram. Okay. So while drawing the diagram, at A there is FA is equals to 7.86. Okay. At FB is equals to 1.86. This is FC. At C there is 1.86. So here it will come 1.86. Okay. And you can observe between C and D, the Fx is minus 1.4. So it will be 1.14, but negative. This is positive. And from D to B it is minus 6.14. So again it will come, it will come like this. For this section there will be same, this will not come, minus 6.14, and this is negative. So this will be your bending moment shear force diagram for a simply supported beam with this much of loading. Always keep it in mind that whenever there is a UDL, in shear force there will be the inclined line, and whenever there are the point load in shear force there will be horizontal rectangles. Understood? So this is about the shear force calculation. Now if we move towards the bending moment calculations, this is our step 3. So MA, as it is a simply support, MB, as it is a simply support, the moment will be 0, but obvious. So we'll calculate first the moment at C. At the point C, if we consider moment, so either rotate the forces on the left side or on the right side. If we consider right side, anti-clockwise will be positive, clockwise will be negative. So for C, we'll rotate all the forces of the right side. So if we rotate the forces of the right side on the C, first will be 5 kN. It will be rotating clockwise. So negative. 5 into 2 will be negative. So MC will be equal to minus 5 into 2. Now rotate RB. RB is rotating in the anti-clockwise direction, so it will be taken as positive. RB's value is 6.14. So 6.14, it will be rotated by the distance 4. So positive 6.14 into the 4. So your answer will come my 14.58 kilonewton meter positive. If you do it on calci, your answer will come like this. Now if we consider the point D, so moment at point D, so consider the right side force as there is only one force, rotate it. So RB will rotate by 2 meter, RB's value is 6.14. so moment at D will be 6.14 into 2 will be equals to 12.28 kilonewton meter. Okay, so we got the moment at C and D. So if we draw the bending moment diagram, okay, so always keep it in mind, if your shear force diagram is inclined line, so there should be curve at this portion. So here the moment is 14.58, and whenever there is a horizontal line, there will be the inclined line in the moment. So here the force is, the value is 12.28, and again here the moment is 0. At MA and MB there is a 0. So there, this is the shear force and bending moment diagram for this particular beam.